In previous videos of Turtles All the Way Down, we've explored the questions of the origin of life on Earth, and also what scientific evidence we currently have for intelligent and not so intelligent alien life. In this video, we'll combine the two ideas and ask slightly different questions. Why the silence? Where is everybody? Today, we'll explore the Fermi Paradox. In the middle of 1950, while taking a lunch walk to Fuller Lodge in Los Alamos, New Mexico, fellow Manhattan Project physicists were discussing interstellar exploration, alien civilizations, and faster-than-light travel. During this discussion, one of the physicists, Enrico Fermi, blurted out, "But where is everybody?" The discussion centered around the idea that we, as a technological civilization, have already begun space travel. Given enough time, it stands to reason that we will eventually be able to routinely travel to other stars. Migrations from star system to star system will proceed, and over the course of a few million years, we will be capable of saturating our entire Milky Way galaxy with humanity's technology and influence. This was just assuming slightly more advanced space travel technology than we already have. Millions of years may seem like a long time, but this is a tiny fraction of both the universe and our galaxy's lifetimes. If we can do it, other alien civilizations can do it as well. But we have no evidence this has ever occurred anywhere. Why? Where is everybody? We've even searched for them and have come up short. This is the so-called Fermi Paradox. It's a bit paradoxical because reasoning seems to show that it's possible, that there has been much, much more than enough time for it to have occurred, and yet no evidence exists that it has. Potential solutions to the Fermi Paradox is what we will explore in this video. Let's look at the three assumptions that are being made with the Fermi Paradox. The first one is that civilizations will have the potential and will eventually reach a stage where they become interstellar and spacefaring. That is to say, the civilization reaches a technology that allows them to travel to the stars. It is very important that you know that this does not necessarily mean that the living species themselves reach the stars, but only that their technology does. Despite the distances involved, this does seem reasonable given enough time. Our own civilization has created space probes that, as we speak, are traveling beyond our solar system and are now in interstellar space between the stars. These are the NASA's Pioneers 10 and 11, the Voyagers 1 and 2, and the New Horizons probe. Needless to say, these 5 spacecraft do not have any living things on them, nor will they reach any nearby stars in at least tens of thousands of years. But this is a proof of concept. We routinely send out probes to planets within our own solar system. This is not at all a problem. And as mentioned, our technology can also reach the stars if we send them out and we wait long enough. So this first assumption is already true, even for our own civilization. Another assumption the Fermi Paradox makes is that once a star system is reached, then that system becomes a source for new space probe emissaries. Like a single seed being planted on a planet which later blossoms and spreads more seeds out from it. More space probes spread from that point. This would mean that the new star system becomes colonized by our technology, and its resources are then utilized to create more probes. Is this a reasonable assumption? If there is one thing we can learn from human civilization, or even from life itself, it is the fact that we spread, we colonize, and we continue the process through local resource consumption. This process is life's engine for growth and change. This is evolution. Without it, life would be an unchanging, fragile, and very vulnerable phenomenon, just waiting for its inevitable demise through natural selection. Growth, spread, and change are absolutely necessary for biological survival. Civilization as a whole also seems to follow the same rules. However, life and civilization's spread, resource utilization, and growth is a double-edged sword. It also produces competition, aggressiveness, and conflict. However, again, the Fermi Paradox doesn't explicitly say that living things themselves, aliens say, are the ones that are spreading and colonizing, but only at a minimum their technology is. So, will technology spread and grow? We really only have one example to look at, and maybe not even that. Of course, our own technology has spread and continues to use resources at ever-increasing rates. However, all of this is due to human control. We are the ones directing what our technology does. If left alone, that technology would not spread and would eventually degenerate into states of disrepair and decay. So really, it is still biological growth that is occurring, but with the technological veneer attached. Unless we succeed at creating AI that can self-fabricate, our technology will be at the mercy of living things, ourselves. A hypothetical self-replicating space probe is called the von Neumann probe. Theoretical design proposals have been partially made for the creation of these devices. In principle, they certainly seem possible, but their actual creation has some extreme AI and technological hurdles to overcome first. But if produced, the big question then becomes how well we can control and direct that technology. Will that technology grow and spread across the galaxy by its own design and under its own control? We don't know. The last assumption made by the Fermi Paradox is that an extraterrestrial civilization smart enough to create this technology exists. Do intelligent aliens even exist? This may be the hardest question to answer. We'll go through a few solutions to the Fermi Paradox. Let's start with that last assumption first. Do aliens even exist? And are they intelligent enough to create the required technology? This is a question that we explored in several turtles all the way down. Watch them here. The study of the origin of life on other worlds and its evolution to intelligence is the concern of the scientific program known as SETI, or the Search for Extraterrestrial Intelligence. The difficulties and probabilities of alien life and ET civilizations can be summed up in the Drake equation. Briefly, it asks what the probabilities are for the major factors needed for producing intelligent civilizations. Many planetary, environmental, biological, and societal hurdles need to be overcome to get from non-living to living things. Then, from primitive to advanced life, and then on to intelligence and civilization. The values for some of the beginning factors of the equation are scientifically well established. For example, the number of stars that are produced in the galaxy each year and the number of them that have planets within their systems are known. However, as we work our way through the Drake equation, the latter factors become increasingly unknown. The diversity of scientific opinions on the values assigned to these factors vary wildly. How likely does life form on Earth-like planets? How often does this life become advanced enough for intelligence? How many of those advanced life forms produce technology? Lastly, how long do those technological civilizations last? These questions are quite speculative, and we only have ourselves to compare to. Some scientists feel that the processes and ingredients required for creating life are so common throughout the cosmos that galaxies may be saturated with life. However, many others opine that abiogenesis, the origin of life from non-life, is so exceedingly remote of a chance that it has essentially only happened once in the entire universe, here on Earth. This leads to the first possible and quite lonely solution to the Fermi Paradox. It may be that aliens just do not exist, not even in microbial forms. It just may be too unlikely to form life, and we happen to be the luckiest ones. The same diversity of thought applies to all the later Drake equation factors, including civilizational technology. The reason for the great diversity of opinion is simply because we have only one example to extrapolate from, Earth's, no others. But perhaps microbial life is common, but is exceedingly unlikely to ever advance beyond this to more complicated multicellular forms. On Earth, this did occur, but it took a long time after single-cell life had already developed. This suggests that multicellular life is very difficult to come by. If multicellular life does occur regularly, it may never, or very rarely, ever reach a point of intelligence where tool-making and therefore technology is developed. Again, look at Earth's evolutionary history. Only a few species, mainly mammals, in all of the billions of species ever formed through evolution, has any kind of technology developed. Only one species ever to the point of getting off of the planet, us, Homo sapiens. Again, higher technology acquisition appears to be an exceedingly rare development for life. So this may be a solution to the paradox. Despite our own example, life just doesn't develop to the point of technology creation. For the sake of argument, let us assume that life in the universe almost always does eventually proceed to technology. Out of all possible and existing alien civilizations that do become spacefaring, there always has to be a first one. Perhaps others are working their way to the stage, but haven't reached it yet. Only one has so far, and that is us. We happen to be the most advanced out there right now. Another timing issue may be that many advanced alien societies do reach the stage, but eventually become quiet or extinct at times when others are looking for them. If either of these cases are true, then of course there would be no detectable evidence for other spacefaring alien civilizations. But if we grant the possibility that other civilizations have developed advanced technology, then other solutions to Fermi's paradox present themselves. Another solution is that civilization-ending technology, such as AI, nuclear weapons, bio and chemical weapons, and other advanced technologies, may almost always be found and used to render self-destruction. Another possibility is that perhaps they do succeed at passing through this dangerous stage in their development. However, the technology requiring interstellar transport of the alien species, or the self-assembling probe AI technology, is an unsurmountable hurdle. Perhaps the will, the time, the resources, and/or the energy requirements may be too high for any civilization to meet. Let's grant some more leeway. Let us assume they have reached the stage of advancement, and they are able to reach other star systems. Why then have we not detected any evidence of them? One solution may be that of timing. Maybe they are in the middle of galactic colonization, but have not yet reached our corner of space to be detectable. Space is enormous and takes a lot of time to cross, even at the fastest speed known, light speed. An additional possibility, which reflects our own technological development, concerns microtechnology. Alien technology could become exceedingly efficient, and resource usage is minimized. Their spacecraft and technology are too small and undetectable with our technology. There could be millions of von Neumann probes in our solar system right now, but are undetectable due to their size. Perhaps they choose not to be seen, and so hide their technology and processes, or camouflage themselves. To add to this line of reasoning, it may be necessary anyway to cloak themselves from us if they themselves are watching us. They may be surveilling our world, or collecting data and cannot be disturbed while doing so. This speculative idea is called the zoo hypothesis. We happen to be the animals the others are looking at. It would be quite easy to hide themselves. How likely are we to find, say, a stealth plane the size of a teapot or smaller, orbiting Earth out near the moon? Maybe there are thousands of them out there with their eyes on us, and we wouldn't be the wiser. We can't assume that they want to be detectable. Again, they could be creating intentional undetectability. There are a variety of reasons this may be. Conflict avoidance, distance surveilling, civilizational disruption avoidance, ethical issues, and others that we can't even imagine. They simply don't want to be seen. As discussed in our previous videos, the SETI community has used multiple technologies to attempt to detect extraterrestrial life and technology. Radio, infrared, and light signals, X-ray and gamma-ray anomalies, and exoplanetary atmospheric spectra. In other words, the full gamut of the electromagnetic spectrum is the playing field for the search for extraterrestrials. Even then, it has been calculated that just in the radio spectrum alone, and within just a portion of our galaxy, the entire range of time, sky, and frequencies that has ever been searched is equivalent to sampling merely a bathtub of water from the entirety of the Earth's oceans, and then concluding that since no fish appear in the bathtub, that no fish exist inside Earth's oceans. Obviously, there is still so much more to study. The so-called search space is absolutely huge. The solution to the Fermi Paradox, according to this argument, is simply that we have barely even begun looking. Even if we had the ability to fully sweep the entire electromagnetic spectrum throughout time and across the entire sky, and still did not detect evidence of aliens, that too will not be the final nail in the coffin. How so? Because there are developing technologies that utilize energies and information of an entirely different nature. For example, gravitational wave detectors are opening a new eye to the universe. This technology is beginning to sense the actual ripples in space-time caused by large amounts of moving masses and energy. Neutrino detectors detect the ephemeral pops of subatomic particles caused by the ultra-rare interactions with neutrinos, the most gossamer of particles. Quantum computers are beginning to make use of the extremely bizarre properties of quantum entangled subatomic particles. Let's not forget about machine learning and AI in general. These emerging technologies have many futurists and technologists worried about our own future and how it may eventually slip from our control. Future AI may have truly alien intentions and goals that do not at all align with humans. Given all of this, perhaps advanced alien technology utilizes non-electromagnetic technologies. It may use gravitational wave generation technology, neutrino or quantum entanglement communication and computing, or maybe a technology we haven't yet reached and that may be many thousands or millions of years ahead of us. How on earth could we ever detect something from these technologies? almost definitely not from listening for radio signals or looking for light pulses. It would be equivalent to asking an Australopithecus, one of our earliest ancestors, to attempt to detect, let alone interpret, a TV, a cell phone, or a computer signal using its current technology. The early primate would have absolutely no idea what these objects were, let alone what they do. If the screens on these devices were turned off and only their internal operations were running, the early hominin wouldn't have a clue anything was happening within them. They would simply appear to be boxes. If alien technological civilizations exist, they will most likely be much, much more advanced than we, due to simple probabilities. What's more is that if we are to judge other advanced civilizations using our own as a guide, we may assume that those extraterrestrial civilizations will almost definitely no longer be of a biological nature. Instead, they would be more of an artificial or machine-like nature. That expectation arises from the inevitable progress of our highly technological society. We can only look at our own histories to see a depressing pattern of civilizational interaction. War and destruction are much too common phenomena to overlook when it comes to how two newly encountered civilizations interact. Almost always, it is the more powerful and most advanced society that decimates the weaker and subsequently spreads its influence and technology. Could this pattern be a common one throughout the cosmos? Can we vicariously forecast our human behaviors to the stars? Is this also how alien civilizations, contacting each other for the first time, will behave toward each other? This may be one of the solutions to the Fermi Paradox. We don't see them because they've been destroyed by others. This leads to the final Fermi Paradox question. If we are to assume all of these possibilities as solutions to the great cosmic silence, isn't it possible that at least one of them manages to escape all of these scenarios and therefore are detectable? Surely it can't be that every civilization wants to stay hidden, or that every civilization's technology is too advanced to be detected, or that every civilization is too far away or gets wiped out, and so on. It would only take a single society to present its existence, a single one to be the exception to these rules. But still, none is forthcoming. Are they all playing by at least one of these rules? So far, yes, they must be. So, the Fermi Paradox. Where is everybody? Life on Earth is a lonely one. We metaphorically yell out to the black emptiness of space. Are we alone? Is there nobody else out there in that great vastness of space? Are we all that there is? And we listen to the silence. But we can't turn away. We've decided it's too important to continue listening. To summarize some solutions to the silence: 1. Life has only happened once on Earth. It's unique. 2. Life has happened elsewhere, but only reaches a microbial stage. 3. Life may be common, but only rarely reaches advanced multicellular stages. 4. Life is common, but rarely develops to the point of technology. 5. Technological civilizations may be common, but destroy themselves with that technology. 6. Spacefaring civilizations cannot feasibly reach or spread to other star systems. 7. Civilizations decide not to spread. 8. Civilizations spread, but we cannot detect them. 9. Alien civilizations destroy each other. 10. Given enough time and technology, we will eventually find them. These solutions seem to cover most of the concerns of the Fermi Paradox. If you have more solutions, please add them to the comments below. Personally, despite what the rare earth and rare lifers have said, and many of their arguments are quite robust, I still remain a SETI optimist. I have always felt that life is a common phenomenon in the universe, as precious and as complicated as it is. However, I have mixed feelings about how far it normally progresses. It's gone very far on Earth, but we have only this one example to reason from. We have no idea about universal statistics. One thing is certain: nature obviously hasn't prevented any of these factors from coming to pass. Earth is a testament to that. Life has developed. It has advanced. It has produced technology that can communicate with and reach the stars. Nothing in nature has completely stopped any of this development from proceeding. This in itself is quite remarkable. My gut feeling is that there are many advanced alien civilizations currently existing, but that our search is much, much too young to detect any. We need more time and perhaps better technology to find them. Remember, the search space is huge, and I would love to think that countless civilizations exist throughout the universe. I believe it's just a matter of time before we confirm it. Let's continue listening to the stars. They may be teaching. Thank you for staying with Turtles all the way down. If you enjoy these big question discussions, please consider subscribing to the channel. Keep up to date on new material. Until next time, keep looking up and stay curious about the world around you. Bye for now.